Today we're going to introduce a topic called polar coordinates. Polar coordinates are just a combination of rectangular coordinates, which is the regular coordinate system that we know normally as x and y, and trigonometry, so angle measures. So polar coordinates are in the form r comma theta, and r just represents the distance from the pole, so that's basically what the origin is, to any point. So it's basically kind of the radius of some circle from our pole, from the origin, essentially. And then theta is the angle traveled from the polar axis, which is essentially the positive x-axis. Now, when trying to graph a point in polar coordinates, we always want to graph the angle first. So you draw your angle measure, and then you go out the value of r. If your measure of theta is negative, you still go in the clockwise direction. Positive still goes in the counterclockwise direction. And then along the pole, or along the terminal side, is going to be the positive values. And then in the opposite direction is a negative value. So we'll take a look at that right now. So we want to plot each of these points in polar coordinates. So first thing that we need to do is plot the angle measure. I'm going to first just draw a coordinate plane. So here we have our basic coordinate plane. So draw the angle measure of negative pi over 4. So we have our pole here at the origin, and then the polar axis, which is essentially just the positive x-axis. And then negative pi over 4, so that's going to be going in the negative direction 45 degrees, or just halfway in between here. So this is negative pi over 4, this measure here. And then we have an r value, so this is r, this is theta. So we have an r value of 2. So that means that once we've traveled our negative pi over 4 units, we're going to travel 2 units out. So essentially we just go 2 units in the direction of our angle measure onto the terminal side. So this point here is the point 2 and then negative pi over 4. If r was negative, like we see in this, we actually, instead of going out in the direction where our terminal side landed, we're going to go back across the pole and keeping on this, essentially just extending our line in the opposite direction, and we're going to go back whatever the distance of r is. So we'll see that here in this example. So again, draw a coordinate plane, or draw the axes. Plot our pole and our polar axis here. And now we need to draw our angle of pi over 4. So pi over 4, that's going to be in the first quadrant here. So here's pi over 4. This measure is pi over 4. And now because r is a negative value, we basically take our terminal side and we have to extend it in the opposite direction. We turn it from a ray into a line. So we have to go backwards this direction. And with it being negative, normally if it's positive, we extend in the direction of the terminal side. But if it's negative, we extend in the opposite direction. So it goes back 2 units. So this point here is our point in B. So it's negative 2 pi over 4. Now the thing about polar coordinates, which is different from rectangular coordinates, all of the points have a unique ordered pair, whereas with polar coordinates, they are not unique. For example, we could also get to this point by traveling this direction and then going out a positive distance, or traveling in a negative direction here. So these points are not unique. And we'll see an example of how we can deal with that in a future example.